All right, so this is my math final. I'm This is solving a base diffusion model, and so basically, base diffusion is it kind of is like a financial model that can show how a new product can be integrated into like a marketplace, say like the new release of the iPhone, 16 or something. And basically, there's a premise of there's two groups. There's the innovators and the imitators. Innovators are the people that discover the product on their own accord. So from like Apple posting their ads on YouTube and them choosing to purchase it, they would be an innovator. And an imitator is someone that buys a product because of someone else. So if I bought the newest iPhone and my friend sees that I bought the newest iPhone and he goes to buy himself as well, he would be an imitator. And then the rate that the product is integrated into the market is dependent on the degree of innovation and imitation. So right here on the top is the graph of the cumulative sales, or you could think of it as like the percent of the marketplace that has adapted this new product. So yeah, and then the bottom is how much sales they're giving how much they're selling at a given point. So if you look here at the greatest amount of sales at a given point is also when our cumulative sales is growing fastest, which makes sense because this is like the graph of the instantaneous change. This top one. We'll come back to this later when we look at like our final equations. This is the base equation we'll start with, the ODE, and basically f of t is the probability that one has purchased the product up to a time t. And this is the important equation that we want to solve for. And then f prime of t, or little lowercase f of t, is the probability of purchasing at a time. At this time, how likely is someone like to get the product based on the innovative adoptive rate, which once again is the someone buying due to like organic ad or something, or Q, the imitative adoption rate, someone buying due to word of mouth or someone else. And over here, you can see that Q is multiplied by F of T because the only way word of mouth can happen is if there's an organic, like if there is someone else that bought it through another source, or if like word of mouth cannot happen if no one's bought it yet, so no one can share about that basically. The more people that have bought it, the more likely word of mouth can happen. So therefore, Q is multiplied by F of T. And this left side, this is basically the probability of purchasing at a certain point given 1 minus f of t, or the percentage of people that have not purchased. So as more people purchase, the likelihood of someone purchasing at this time will decrease because more of the market's saturated. So if there is originally 100% of the market has not bought it, then someone is more likely to buy it because we know for a fact that this person is going to be a buyer. But if, say, 50% of the market has already bought this item, there's a 50% chance that a random person would already have it. So the likelihood of a purchase happening at this given point will decrease. And this 1 minus f of t accounts for that. And over here, this is basically me solving the ODE. Yeah, this is basically me solving the ODE. Right here, I end up separating separating the variables, and then I can integrate. And this looks a lot like a quadratic at the bottom. So I used the quadratic formula to find my roots, to get this in factored form. And this factored form, now that it's in factored form, it is easy to use partial fraction decomposition, which will help me integrate it later on. And as I integrate it, I get all my natural logs and all that stuff. And then to go back, the integration of the left side dt, I get t plus c because there might be another constant that we're not sure of, as it's an indefinite integral. And over here is me isolating our f of t, which is basically what we're looking for. Doing all this algebra and stuff, arithmetic, and then I get f equals this, but we still have an unknown constant in our answer. And to solve for that, I examine at time 0, and I figure that C is equal to P, which is the innovative rate. And looking at this, my final equation comes out to be this. All right, now we're going to analyze the base diffusion model in Desmos to see what happens. Remember, P is the organic growth, or like the people that are the likelihood of someone purchasing due to seeing an ad, and Q is the likelihood of someone purchasing due to the spread of word of mouth, like influence from someone else. So as Q, which is word of mouth, the percent of someone likelihood, like the likelihood of someone buying due to word of mouth increases, there's no reaction from the graph because our P, or like the people buying it organically, is 0. There is no reaction from a graph because if there's no one originally to buy the product, and without word of mouth, there's no one to then spread it. And if there's no one to spread it, it's like a disease, right? If there's no first patient, then there's no spread of the disease. Now let's look at what happens when our P increases, which is the likely, like how effective your ad is. Like say 50% of the people purchase from your ad. This is your graph. But obviously, as your ad is more effective, the quicker you are to reach that full market saturation. And now let's see what happens when we have a good effective ad and we have good word of mouth spreading. This is what most ideal companies want. This will, with good word of mouth, this will even more effectively bring them closer to their market saturation, even quicker. And we can even compare it to like this. This is somewhere around 5.9. You'd say this shows how effective like word of mouth is. This will get you to your max at it earlier with a good word of mouth. So that's why this is like shows how companies sometimes will value word of mouth over the effectiveness of their ad. But yeah, in collaboration, both are very effective. Now this is the derivative of that previous graph. So this basically shows how quick sales are being made, how fast the market is being saturated, and how fast people are buying this product. And once again, with like as the imitation, like as the word of mouth percentage increases, nothing happens because there's no one to obviously spread the news about this product. So as the effectiveness of your ad, like this is the model of based on the effectiveness of your ad. Once your ad is super effective in the beginning, so the amount of people buying your product is super fast in the beginning, but it will slow down. Like the amount of your product being sold will slow down because now more of the population already has your product, so people buying will be less. And here, this is like a healthy business where there isn't super not not all their product is being bought at once. Rather, it's rather smooth and cyclical like this. And this is why businesses want a good ad efficiency, but also a good word of mouth, so that their business can last for a longer period of time, rather than completely saturating the market at once. And this graph shows this with like no huge drop and no huge spikes. So yeah, this is basically my presentation on the base diffusion model in like for businesses, and this was just something interesting to me because I like business and I like math. So yeah, that's my project. Thank you.